So we're going to talk about solving proportions today. I want to start with something that you've seen. We've seen things like this. 3 over 6 equals 12 over 24. And I ask you, is this true? Right? And there's two ways to solve that. You can try to reduce. So if I reduced, let's see, 12 goes into both of these, and 3 goes into both of these. So I would have 1/2 equals 1/2, and I could say this is true. The other way to solve it is, what's it called? Ben? Cross multiplying. So if I had 3 over 6 equals 12 over 24, what does that mean, cross multiply? What numbers am I going to multiply on the left? Yeah.
Multiply 3 by 24 and 6 by 12.
Yeah. When you say and, does that mean plus?
No.
3 times 24 and 6 times 12? What goes in between them? Equals. We can't lose our equal sign here. Right? So we cross multiply across, just like Andrea said, 3 times 24 over here, and 6 times 12 over here. Yeah, and we would find 3 times 24 equals 72, and 6 times 12 equals 72. And we could also say that this is true. So we have two ways of doing this. Okay. This is review. You've seen this. And then what happens is we have one like this. 3 over 7 equals 12 over 5. So the first thing we do is we look at it, can we reduce?
Yes.
Is there anything that goes into 12 and 5?
No.
Is there anything that goes into 3 and 7? No. So I can't reduce, so I'm just going to cross multiply. Does it matter which one I do first?
No.
No, I could do this one first this time. So 7 times 12 equals 3 times 5. So 7 times 12, 70 plus 14, that's 84, equals 15. And this is false. And you've seen both of these types before. Some are true, some are false. Now the question is, if we have one that's false, how could we make it true? And what you'll see, instead of numbers, we'll say, okay, so we know this isn't true. So what if we put a variable here? What if we put an x? What would x have to be so that this proportion would be true? So now I have x over 7 equals 12 over 5. And the way you're going to solve this is to first reduce if you can, but I can't, and then cross multiply. And what we'll get when we cross multiply? 7 times 12, still 84. What is x times 5?
5x.
5x, yeah. So x times 5 is written as 5x. And this just means 5 times x. So we write it like that, 5x. Now the way to solve this, it's always going to be the same step. You're going to divide both sides of your equation by whatever the number in front of x is. Okay, and I'm going to write that. I want you to write this in your notes. Divide both sides of your equation by the number anyone know the term for that? The number in front of a variable? What is that called? Mira?
Well, I don't know, like 5.
Okay, hold on a second. Gideon?
I can't see.
Okay. It's called the coefficient. Yeah, very good. That's right, Cass. So we're dividing both sides by our coefficient. What is 5x divided by 5? Does anyone know? Yeah, it's just x. So when we have a problem like this, we can split it up. This is the same thing as 5 divided by 5 times x divided by 1. 5 divided by 5 is 1. And x over 1 is just x. And then 84 over 5, is there any way to reduce that? 5 is a prime number. So in order to reduce this, 5 would have to go into 84. And it doesn't. Our answer is just going to be 84 fifths. We say x equals 84 fifths. And I want you to leave it like that. You've probably been taught that that is an improper fraction. And you should divide 5 into 84, put your number out front and your remainder over 5. We're not going to do that. You're going to leave improper fractions as they are because they're actually numbers and they're easier to work with now. So that would be your answer. You put a box around it. Yeah?
Okay, so my question was, like, you know how, like, at first we wanted to make the whole statement true? So, would it matter, like, if instead of taking out 3 from 3 over 7, would it matter if we took out, like, the 12 from 12 over 5, like, would it matter if we took 1 from 12?
It wouldn't matter. And you'll see them done all sorts of ways.
So, like, either way would equal F
Yeah.
equals 8.
Now, I'm not actually going to give you a false statement and say make it true on your homework tonight. I'm just going to already have the x's in there, or whatever variable. So you don't have to make that decision. But Mira's totally right. We could take out this number, right? We could take out any one of these numbers and find something that would make it true. Now, it's not necessarily a very pretty number. If you think about this, what we just found is that this is the true proportion. 84 over 5 over 7 equals 12 over 5. Because this is x, and that's where x was over here. That's not a very nice number, right? It's kind of hard to work with. Now you can check your work by doing this, right? So if I check my work, when I cross multiply, it actually won't be that difficult. I'm going to take 84 over 5 times 5. Well, that's not too hard. That actually worked out nicely, and it will always work out nicely. So 84 divided by 5 times 5, those just cancel. On this side I have 84, equals 7 times 12. And this is called plugging in to check. Plug in to check. Okay? So I took my x and I put it back in here. Okay? In order to check if my answer is correct. If it doesn't work out nicely like that, then you've probably done something a little off. And then you just go back and try again. And then you'll get it right. So let's do a couple more examples. First example, I just used a different variable, right? N instead of x. It doesn't change the way we're going to do this. So n times 9, that's 9n. Remember, we're going to always write it like that. Equals 3 times 6, which is 18. Divide by the coefficient on the variable. What's the coefficient on our variable? 9. So I'm going to divide by 9. So I have n equals 18. Why are you shaking your head? Yeah, you can't just divide one side. Silly Nate. You have to divide both sides by that 9. So 18 divided by 9 is 2. Now I'm going to plug it in. 2 over 3. N is 2. So 2 over 3 equals 6 over 9. I've been cross multiplying, but there's actually an easier way to do this problem. What is it? Yeah, what if we just reduced this? What goes into 6 and 9? 3. How many times does 3 go into 6? 2. And how many times does it go into 9? 3. So 2 over 3 equals 2 over 3. Is that true?
Yeah.
So our answer checked. That worked. Now I actually could have done that up here, and I could have saved myself a whole bunch of steps. So sometimes you'll get a problem like this where you don't have to cross multiply. Because if I had done, so let me show you what I mean. If I had started with n over 3 equals 6 over 9, if I had reduced first 2 over 3 before even solving, n over 3 equals 2 over 3, then n is clearly 2, right?
Yeah.
Because I know it's 2 over 3 over here, so in order for this to be the same, n has to be 2. So that's another way of solving, but it won't always work. Right? You always want to look for your reducing, but you might not be able to reduce. So let's do the next example. Since I just said that, can I reduce anything here?
No.
No. Okay, so I'm stuck with cross multiplying. 2 times 7 equals, what do I write instead of 1 times m? Yeah, 1 times m is just m. 2 times 7 is 14, and that's my answer. M equals 14. I'm going to plug it in over here. 1 over 2 equals 7 over 14. Now, when I'm checking, I can reduce, right? What can I reduce? Well, 7 goes into 7 once, and 7 goes into 14 twice. So when I check my answer, I see 1/2 equals 1/2. And that's true, so it checks out. Okay, last example. X over 11 equals 3 over 4. X over 11 equals 3 over 4. So, anything I can reduce there? No. So x times 4, which I'm going to write as 4x, equals 11 times 3, which I'm going to write as 33. Next step is to divide by my coefficient. I'm going to remember to divide both sides. So x equals 33 over 4. 4 is only divisible by 2. 33 is not, so I can't reduce that. That's my answer.
Wait, is it okay to leave a fraction as an answer?
Yeah.
What? Are you serious? That's really okay? Wow, that's pretty easy. Pretty cool. 33 over 4. That's your answer. You don't have to turn it into a mixed number. Just leave it as a fraction.
Okay, now I'm going to check my answer. And like I said, this is going to work out nicely if we do it correctly. So remember, this is my numerator. 33 over 4 is my numerator. It's a fraction, but it's also a number. Right? Every fraction is a number. If you typed that into a calculator, it could give you a decimal. Right? Be 8.25 or something like that. So this is a number. It can be a numerator. When I plug it in, I'm going to cross multiply this whole thing, 33 over 4, cross multiply that times 4, and I can already see that that's going to work out nicely. So it's not that hard to check these. Equals 3 times 11, this one times this one. 33 divided by 4 times 4 is just 33. 3 times 11 equals 33. So my answer checks. I know it's true. And then I want to go box my answer, and I know it's right. I've checked it. Double checked it. I've triple checked it. If it's a test, I've quintuple checked it. Dodeca checked it.
Why is he talking about checking and
It's
like
important.
on tests and stuff?
I'm going to stop the video, I think.
Just gotta go. So Ben.